Okay, so in this question, we're given that log to the base x of 64 equals 2, and we need to solve it for x. So let's begin that. So part A, we're given log x of 64 equals 2, and the way we're going to solve this is that we're going to rewrite this in index form. So this is equivalent to x to the power of 2 equals 64. So let's write that. So x to the power of 2 equals 64, and now we can solve this. So we can square root both sides. We get x is root 64 plus and minus, and 64 is a square number, so that's equal to plus minus 8. But we are told that x has to be positive because we can't put a negative as the base of a log. So therefore x equals positive 8 is the solution. Okay, part B. So part B is different. It doesn't use any of part A. And we're given another log equation, log base 2 of 11 minus 6x equals 2 times log base 2 of x minus 1 plus 3, and we need to solve this for x. So if we look at the equation, we can see that there's 3 terms. 2 of them have got logs and the other one doesn't have a log. And the method when we have that is we need to get all the logs to one side and everything else to the other side. So let's do that. So let's copy the first term that's already there. So log base 2 of 11 minus 6x, and let's move over that term. So minus 2 log base 2 of x minus 1, and that equals 3. And now that all the logs are on the left, the next step is to somehow join them up into one big log. And this minus means that we can join it up with a division, but before we do that, we can't quite do that just yet because the 2's in the way. So we need to get rid of this 2, and we can bring the 2 in as a power. So let's do that. So log 2 of 11 minus 6x minus, now let's move that 2 inside the log as a power. So that's log base 2 of x minus 1 squared, and that equals 3. And now that there's nothing in front of this log, we can join up the 2 logs using the division rule for logs. So this becomes log base 2 of 11 minus 6x over x minus 1 all squared, and that equals 3. Okay, so now that we only have one log over here, we can now put this in index notation. It should be 2 to the power of 3 equals all of this. So let's do that. So 2 to the power of 3 equals 11 minus 6x over x minus 1 all squared. And now we can solve this. So this is an 8, and we'll times up the x minus 1 all squared over here as well. So therefore 8 x minus 1 squared equals 11 minus 6x. And now we'll expand this bracket here, the double bracket. So 8, that's x squared minus 2x plus 1 equals 11 minus 6x, and then we'll expand this bracket here. I'll do that down here. So 8x squared minus 16x plus 8 equals 11 minus 6x. And let's bring everything to the left. So we have 8x squared minus 10x minus 3 equals 0. And we need to solve this quadratic We can do any method, but since we have access to the calculator in the exams, I'll solve this with the calculator. So it's 8 minus 10 minus 3, and we get two solutions. X equals 3 over 2 and x equals minus a quarter. But now we have to be a little bit careful when we have logs. You can't just plug anything into a log. The answers can be negative, that's not an issue. It could be negative or positive. The issue is if you substitute it in to the original, we mustn't get a negative. So let's just test. For example, x equals minus a quarter. If we were to plug that in to the original into here, that's x minus 1. Minus a quarter minus 1 is a negative, and you can't plug a negative into the log. So this one, we have to exclude this solution. This will not be acceptable. So we can't do that, but let's test the 3 over 2. That's 1.5. 1.5 minus 1 is still positive, so that's okay. If we plug 1.5 into here, let's just do that. You get 11. 11 minus 6 times 1.5, and that's 2, so that's still positive. So that means this solution is okay. Therefore, there's only one solution, x equals 3 over 2. And you would have to be sure to not put minus a quarter as a solution, otherwise you lose a mark.